This is question number 35 from the August 2017 Geometry Regents exam. This is a pretty involved question, and we're trying to prove that triangle ADE in this diagram, so this triangle here, is congruent to the triangle BCE, which is this one opposite over here. And we also have to prove that the triangle in the center here, AEB, is an isosceles triangle. So that may seem extremely overwhelming, but if we are able to prove that in the diagram here, this the green and blue triangles are congruent, we could conclude that these are equal side lengths, and then finally conclude that AEB is isosceles. So kind of the first proof leads to the next one. So once we prove that these two triangles are congruent, we can get to the last step pretty quickly. At any rate, let's start by starting the statement of what is given to us. We know that ABCD is an isosceles trapezoid. The line AE and DE are perpendicular, so we can label that here. BE and CE are also perpendicular, and we also know that angle CDE is congruent or equal to DCE. So this angle here and this angle here are equal. Now, the first useful thing we can figure out is that because this is an isosceles trapezoid, we can conclude that the line from B to C and A to D are equal in length. They are congruent to each other. And what we're trying to get at here is I'm trying to get to the fact that we can prove that the two triangles here, ADE and BEC, are congruent, right? We're trying to get to that point. So far, we've got two side lengths that are the same, two angles that are the same. So we're almost there. But we should write down a couple statements showing that we are aware that these two are congruent angles. So you can see in a couple of statements I've added that angle DEA and CEB are right angles. We know that because, of course, perpendicular lines form right angles. Therefore, DEA and angle CEB are congruent because, all right angles are congruent. They're all 90 degrees. Next, I'm going to do is I'm going to demonstrate that the angle here and here are equal to each other. And we know that's the case because the base angles of any isosceles trapezoid are always going to be equal to each other or congruent. Now, the reason saying that information is useful is because we're trying to show that, here, let me pick a different color. We're trying to show that this angle here and this angle here are equal or congruent. And we can do that by some subtracting. So if we take this red angle and subtract the black one, you would get this purple angle. And you would get the exact same angle on both the left and the right side here. Again, by taking the red angle and subtracting the black angle, you get the purple one. So you can see in the statement there, I showed some of that math. What I just explained in words using some subtraction here. So angle CDA minus angle CDE is congruent to if we were to subtract angle DCB minus angle DCE, and then you end up with angle EDA being equal to or congruent to angle ECB. And that's based on the subtraction postulate, which basically just states that if equal quantities are subtracted from equal quantities, the differences are going to be equal. Okay, so we've now reached a point where we can actually state that the two triangles are congruent, and this is because of using angle, side, right? We can see an angle here, and side in both cases. So we officially have the first part of the question done. We have proven that those two triangles are congruent. Now, to show that triangle AEB, this guy in the center here, is isosceles, we just got to show that these two side lengths are equal. And we can actually state that right away because we know that corresponding parts of congruent triangles are congruent, or the good old acronym CPC-TC. And we've done it. Now we can basically say that triangle AEB is an isosceles triangle because, I mean, that's just a definition of an isosceles triangle. If it has two congruent sides, it's isosceles. So you can see that little addition to finish off our statements and reasonings. Whew, all right, yeah, that was a pretty intense question. I hope this video helped give you a better idea of how to prove it. And yeah, that's it for this video. Thanks for visiting JD's Regents Preparation.